A Japanese car company just got the green light to build a battery that can take an electric car about 750 miles on one charge, and it can refill that battery in around 10 minutes. That's not a dream. That's not a car hidden behind glass at some faraway trade show. In October of 2025, this battery got official approval for mass production in Japan. That is a real, government-approved, going into real cars kind of approval. The factory that will build it is set to open in 2026. Let's slow down and think about what that means. Most electric cars on American roads today go somewhere between 250 and 320 miles on a full charge. The longest range electric cars money can buy today push past 400 miles, but only a few, and only if you pay a lot of extra money for them. This new battery could push past 700 miles. That is not a small step forward. That is a huge jump, almost double what a normal EV driver gets today. And here's the part that might surprise you. Now, the company behind this isn't some brand new startup with a flashy name you've never heard of. It's Toyota. Yes, that Toyota. The same company a lot of people online love to make fun of for being slow on electric cars. The same company that kept building hybrids while other brands went all in on EVs. For years, people said Toyota was falling behind. Turns out, Toyota may have been playing a completely different game the whole time. If stories like this get you excited, tap that like button and hit subscribe so you don't miss the next one. We dig into car and tech shifts that most people won't notice until it's already changed everything. Because here's the wild part. The man whose ideas built Toyota didn't start with cars at all. He started with sewing looms in a small village with almost nothing. His name was Sakichi Toyoda, and the company he built out of nothing is the reason Toyota exists today. The battery breakthrough we're about to talk about traces its roots all the way back to him. And by the end of this video, you'll understand why car companies all over the world, from Detroit to Shanghai, are watching Japan very, very closely right now. The carpenter's son who never stopped inventing. To understand why this battery matters so much, we need to go back more than 130 years to a small village in Shizuoka, Japan. That's where Sakichi Toyoda was born in 1867, the son of a poor carpenter. Nobody in that village was dreaming about cars. Most families were farming rice and weaving cloth by hand just to get by. Sakichi grew up watching his mother and the other women in the village weave cloth on old wooden looms. It was slow, tiring work. Every thread had to be checked by hand. He kept thinking there had to be a better way. So he started building things. In 1891, at just 24 years old, he earned his first patent for an improved wooden loom. He wasn't trained as an engineer. Nobody handed him money or connections. He simply would not stop trying to make things work better. Over the next 30 years, Sakichi kept inventing, failing, and inventing again. His biggest breakthrough came with something called the automatic loom. This machine could weave cloth on its own, and it was smart enough to stop itself the moment a thread snapped. That single idea, a machine that knows when something is wrong and stops itself, became so important that it later got its own name, Jidoka. It's still one of the core ideas behind how Toyota builds cars today. People started calling Sakichi the king of Japanese inventors. He became known as the father of Japan's Industrial Revolution. In 1929, a British company called Platt Brothers, one of the biggest textile machine makers in the world, wanted the rights to build Sakichi's automatic loom outside Japan. They paid him about 1 million yen for it, worth around $150,000 at the time. That might not sound like a huge number today, but for a carpenter's son who grew up with nothing, it was enormous. And Sakichi didn't spend it on himself. He used almost all of it to fund his son, Kichiro's next big dream, building cars. Sakichi passed away in October of 1930, just 1 year later. He never got to see his son's dream come true. But in 1937, Kichiro Toyoda used that money and his father's obsession with building things better to officially launch the Toyota Motor Company. From a wooden loom in a farming village to one of the biggest car companies on earth, all because one man refused to accept good enough. That same stubborn drive, the refusal to settle, the belief that everything can be made better is exactly what's showing up again nearly a century later. Except this time, it's not about looms or engines. It's about what's inside the battery pack. Why just buy an EV isn't as simple as it sounds. Before we get to the battery breakthrough, we need to talk honestly about why regular electric cars still aren't the perfect answer for a lot of people. Electric cars are genuinely amazing technology, but living with one day after day has some real problems that don't show up in the commercials. Let's start with charging speed. Companies love to show happy drivers plugging in and walking away in seconds. In real life, even the fastest public chargers today usually take somewhere between 20 and 40 minutes just to get a battery back up to 80%. That's not a quick stop. That's long enough to eat a meal or watch part of a show. On a solo drive, that's a mild annoyance. With tired kids in the back seat and a schedule to keep, it can turn into a real headache. Then there's cold weather, and this one catches a lot of new EV owners off guard. A major ALOA study from early 2026 tested real EVs in freezing conditions and found that when the temperature drops to around 20 degrees Fahrenheit, EVs lose close to 39% of their range on average. Other big studies, using data from tens of thousands of real cars, have found similar numbers, usually somewhere between 20 and 45% range loss in true winter conditions. So if you paid for a car that promises 300 miles of range, a cold January morning in Minnesota or Michigan might quietly turn that into less than 200 miles. That's a big gap between the sticker and the real world. Battery aging is another quiet worry. Lithium-ion batteries, the kind almost every EV uses today, slowly lose some of their capacity over time, just like the battery in an old phone. Recent research tracking more than 20,000 real EVs found an average battery degradation of a little over 2% per year. That adds up. And when a battery does eventually need major repair or replacement, the bill can be one of the biggest single repair costs a car owner will ever face. There's also a bigger, quieter issue that doesn't make it into most ads: where the materials come from. Building today's EV batteries takes lithium, cobalt, and nickel. Digging those materials out of the ground is not a clean, simple job. It involves huge mines, real environmental damage, and, in the case of cobalt especially, serious and well-documented human rights concerns in some of the regions where it's mined. And on top of all of that, there's the power grid itself. In the United States, the electrical grid was built decades ago, long before anyone imagined tens of millions of cars all plugging in at once. Experts have been warning for years that upgrading the grid to handle mass EV charging is a massive, expensive, slow-moving project, and it's nowhere close to finished. None of this means electric cars are bad. They're not. But for a huge number of people, going electric right now isn't a simple upgrade. It's a real trade-off with real compromises. So the question becomes, what if engineers could fix the actual battery itself at the chemistry level instead of just building bigger versions of the same old battery? That is exactly the question Japan's biggest car companies have spent the last several years trying to answer. And the answer they're building is something the rest of the industry did not expect this soon: the battery that broke the rules. Every lithium-ion battery today, the kind in your phone, your laptop, and almost every EV on the road, uses a liquid electrolyte. Think of the electrolyte as the material inside the battery that lets electrically charged particles move back and forth between the two ends of the battery. That movement is what actually creates useful power. The problem is, liquid electrolytes are flammable, they take up a lot of space, they need thick protective layers to stay safe, and they slowly break down every time the battery heats up and cools down. A solid-state battery swaps that liquid out for a solid material instead, usually a special kind of ceramic or crystal-like substance. No liquid sloshing around inside. That single change unlocks a chain reaction of benefits. Without the liquid, the battery can be packed much tighter, which means more power squeezed into the same amount of space. Without the liquid, there's far less risk of fire. And because the solid material handles heat and cold much better than a liquid does, the battery can charge faster and last longer without wearing down as quickly. Toyota has been chasing this idea for over a decade, working closely with two other Japanese companies: Idemitsu Kosen, a major oil refiner that also happens to be an expert in the special solid materials these batteries need, and Sumitomo Metal Mining, which developed a highly durable material for the battery's positive end. On October 7, 2025, Toyota's solid-state battery officially received production approval from Japanese authorities. That's a formal government green light to move from lab prototypes into a real factory. Toyota is now planning a battery factory in Japan with a yearly production capacity of 10 gigawatt hours, set to come online in 2026. Here are the numbers that matter. Toyota's first generation of solid-state batteries is expected to give EVs a driving range of around 1,000 kilometers, which is about 620 miles, and to charge from 10% to 80% in roughly 10 minutes. Toyota is targeting this for 2027 or 2028, and reports suggest the very first cars to get it will be flagship Lexus models. A second generation is already in development behind that, aiming for up to 1,200 kilometers or about 745 miles on a single charge. To put that in perspective, Toyota's own best current lithium-ion battery, the one it's calling its performance battery, is expected to deliver around 800 kilometers, or about 500 miles, when it launches in 2026. So even before the solid-state version arrives, Toyota is already stretching what a single battery can do. The solid-state version isn't just a small upgrade over that. It's a 20 to 50% jump on top of an already improved battery. Toyota isn't approaching this quietly either. The company now holds more than 1,000 patents related to solid-state battery technology, more than any other automaker on Earth. That's not a company dabbling in a side project. That's a company that decided years ago this was the technology worth betting the future on, and quietly built a wall of intellectual property around it, while most of the world was focused on other things. What 745 miles actually feels like numbers on a spec sheet can be hard to picture, so let's translate this into something you'd actually feel behind the wheel. Right now, if you own a typical EV with roughly 300 miles of range, a road trip means planning your day around charging stops. You drive for a few hours, then you sit at a charging station for 20 to 40 minutes, then you get back on the road. It works, but it changes how you travel. Now picture a car with 745 miles of range. That's enough to drive from Los Angeles to Denver without stopping once for a charge, and still have miles left over. In everyday terms, most drivers wouldn't need to charge more than once or twice a week, even with regular use. A daily commute, errands, a weekend trip, all of it on one charge that lasts most of the week. And then there's the charging speed itself. 10 minutes is close to how long it takes to fill up a gas tank and grab a coffee. That's the number that really changes the conversation, because it starts to erase the single biggest complaint people have about electric cars: standing around waiting. It's worth being fair here and mentioning the competition, because Toyota isn't the only one chasing fast charging. A California-based company called QuantumScape, backed by Volkswagen, has developed its own solid-state cells that can charge from 10 to 80% in about 15 minutes, with a very high energy density of 844 watt-hours per liter. QuantumScape opened a new pilot production line in San Jose in February of 2026 and expects small-scale commercial production by 2027. So while Toyota is currently ahead on projected driving range, the race for fastest charging is close, and it's global. The race nobody outside Japan is watching closely enough. Here's what makes this moment bigger than just one company's announcement. Toyota isn't the only Japanese automaker racing towards solid-state batteries. Two of its biggest domestic rivals are running the exact same race at almost the exact same time, and most people outside Japan haven't noticed. Honda unveiled its own solid-state battery demonstration production line in November of 2024, built at a research facility in Sakura City in Japan's Tochigi Prefecture. The factory covers about 27,400 square meters, roughly the size of 5 football fields, and represents an investment of around 43 billion yen, close to 287 million. Honda began actually producing test batteries on this line in January of 2025. The company's goal is to have solid-state batteries in real electrified vehicles by the second half of this decade, meaning somewhere around 2027 to 2029. Nissan is running its own version of this race too. The company has built a pilot production line at its Yokohama plant, aiming to launch its first EV with an in-house all-solid-state battery by fiscal year 2028, possibly stretching into 2029. Nissan's targets are ambitious: an energy density of 800 watt-hours per liter, roughly double what today's lithium-ion batteries deliver, along with much faster charging. Nissan says it wants to bring battery costs down to $75 per kilowatt-hour by 2028, and eventually to $65 per kilowatt-hour, a price point that would put electric cars on the same cost level as gas-powered ones. 3 of Japan's biggest automakers, longtime rivals in almost every other part of the business, are all racing toward the same battery technology at nearly the same time. That's not a coincidence. Japan's government has been actively supporting this push too, funding research through programs like the Green Innovation Fund and approving major new factory projects, including the large-scale solid electrolyte plant that Idemitsu Kosan broke ground on in January of 2026 to supply Toyota. When an entire country's biggest industry starts moving in the same direction at the same time, backed by government money, that's usually a sign something serious is happening. The rest of the world is racing too. Japan isn't operating in a vacuum here. China and the United States are both pouring enormous resources into solid-state batteries as well, and the picture gets a little more complicated once you look at what they're actually building right now versus what they're promising for later. In China, CATL, the world's largest battery maker by far, has said it's targeting small batch production of true all-solid-state batteries by 2027, with real mass production not expected until closer to 2030. As of 2025, the company rated its own technology at a 4 out of 9 on an industry maturity scale, aiming to reach a 7 or 8 by 2027. CATL's chief executive has publicly pushed back on rumors of an earlier mass production timeline, saying full commercialization by 2030 is unlikely, and that early versions will probably only appear in expensive premium vehicles first. BYD, China's biggest EV maker, showed off its own sulfide-based all-solid-state battery at the Beijing Auto Show in April of 2026, boasting an energy density of 480 watt-hours per kilogram, with small batch vehicle installation planned for 2027. Another Chinese automaker, Chery, showed a battery hitting 600 watt-hours per kilogram at that same show, one of the highest numbers publicly demonstrated anywhere in the world. But it's worth being clear about something important. Most of the solid-state batteries already on Chinese roads today In cars, like certain Neo and IM models, are actually semi-solid or condensed batteries. They still contain a small amount of liquid electrolyte. They're a real step forward, but they are not the same as a true, fully solid battery. In the United States, QuantumScape remains the name to watch. Backed by Volkswagen's battery arm, PowerCo, the company opened its new Eagle Line pilot production facility in San Jose in February of 2026. Its QSE5 solid-state cells have already been shipped to Volkswagen for testing, and the technology got its first public demonstration in September of 2025, powering a Ducati electric race motorcycle on stage in Munich. QuantumScape is aiming for low-volume commercial production by 2027, working through licensing deals rather than building factories on its own. So here's the honest scoreboard as it stands. Toyota currently holds the most concrete government-approved production timeline, with an actual factory set to open in 2026 and cars expected by 2027 or 2028. China has some of the highest lab-reported energy density numbers and a huge industrial base ready to scale fast once the engineering catches up. The United States has strong industrial partnerships and a technology that's already been demonstrated in a real moving vehicle. Nobody has fully won this race yet, but Japan, quietly and without much fanfare, currently has the clearest, most official path to actually putting these batteries in customer cars first. What this actually means for you. So what does all of this mean if you're just someone thinking about your next car? If these batteries deliver what's been promised, driving an EV could start to feel a lot more like driving a gas car, just better. Instead of planning trips around 20 to 40 minute charging stops, you'd be looking at roughly 10 minutes, similar to filling up a tank and grabbing a snack. Instead of watching your range shrink by a third every winter, a solid-state battery's better tolerance for temperature swings should help protect against that steep cold weather range loss. Instead of quietly worrying about your battery wearing out and facing a massive repair bill years down the road, a more stable battery chemistry should age more slowly. It's worth being honest about the limits here too. Solid-state batteries still need lithium, and depending on the exact chemistry, some designs still rely on other mined materials. This isn't a technology that erases every environmental question around EV batteries. But a battery that lasts longer, charges faster, and holds up better in the cold is still a real, meaningful step forward, both for drivers and for the amount of energy and material wasted on batteries that wear out too soon. For the auto industry, this is a genuine wake-up call. For years, the assumption was that Toyota, Honda, and other Japanese automakers were dragging their feet on electric cars, letting companies like Tesla and BYD run away with the future. What's becoming clear now is that at least one of those slow companies may have spent that time building something the rest of the industry can't easily copy, a decade-long head start on the battery technology that could define the next generation of EVs. Car companies that assumed liquid lithium-ion batteries were the only path forward may soon find themselves years behind on a technology that customers are going to want the moment it becomes available. The son of a poor carpenter once refused to accept that weaving cloth by hand was good enough, and that stubborn refusal eventually built one of the largest car companies in the world. Nearly 100 years later, the company he helped create is refusing to accept that today's batteries are good enough either. And the industry that once wrote off Japan's automakers as too cautious, too slow, and too stuck in the past may be about to spend the next few years trying to catch up. If this video showed you something you didn't know about before, tap that like button and subscribe so you don't miss what comes next. Turn on notifications too, because the next story out of Japan might be even bigger than this one. Now I want to know what you think. If a solid-state battery really could give you a 745-mile range and a 10-minute charge, would that finally be enough to get you into an electric car? Drop your answer in the comments below.